What's a correct and good way to implement _hash_? What's a correct and good way to implement _hash_? I am talking about the function that returns a hash code that is then used to insert objects into hash tables, aka dictionaries. As _hash_ returns an integer and is used for binning objects into hash tables, I assume that the values of the returned integer should be uniformly distributed for common data, to minimize collisions. What's a good practice to get such values? Are collisions a problem? In my case, I have a small class which acts as a container class holding some ints, some floats and a string.
An easy, correct way to implement _hash_ is to use a key tuple. It won't be as fast as a specialized hash, but if you need that, then you should probably implement the type in C. Here's an example of using a key for hash and equality. Also, the documentation of _hash_ has more information that may be valuable in some particular circumstances.
John Millikan proposed a solution similar to this. The problem with this solution is that the hash A, B, C equals hash A, B, C. In other words, the hash collides with that of the tuple of its key members. Maybe this does not matter very often in practice. Update: the Python docs now recommend to use a tuple as in the example above. Note that the documentation states the only required property is that objects which compare equal have the same hash value. Note that the opposite is not true. Objects which do not compare equal may have the same hash value. Such a hash collision will not cause one object to replace another when used as a dict key or set element, as long as the objects do not also compare equal. Outdated/bad solution, which gives us this. Update: as BLCKKNGHT points out, changing the order of A, B, and C could cause problems. I added an additional hash self.A, self._B, self._C, to capture the order of the values being hashed. This final hash ... can be removed if the values being combined cannot be rearranged. For example, if they have different types and therefore the value of A will never be assigned to _B or _C, etc.
Paul Larson of Microsoft Research studied a wide variety of hash functions. He told me that works surprisingly well for a wide variety of strings. I found that similar polynomial techniques work well for computing a hash of disparate subfields.
A good way to implement hash, as well as list, dict, tuple, is to make the object have a predictable order of items by making it iterable using _iter_. So to modify an example from above. Here _eq_ is not required for hash, but it's easy to implement. Now add some mutable members to see how it works. Things only fall apart if you try to put non-hashable members in the object model.